In today's video, we're going to be looking at the laws of indices. Okay, and a power or an index is used to write a product of numbers very compactly. So the plural of index is indices. So if we're looking at an index, that's just one sort of power, and then if we've got multiple, then those are just indices. So if we could just do a quick recap, for example, we know that 3 squared, for example, is just equal to 3 times 3. So that denoting that it's to the power of itself twice. So 3 times 3 is 3 squared. If we were going to say cubed, that would simply be 3 times 3 times 3. Okay, but that should be pretty basic, and should be the sort of maths that you've been doing for a long time. But now, if you're doing A-level maths, then you should be looking at specific laws of indices. So to manipulate expressions involving indices, we use specific rules known as the laws of indices, which are, and some of these rules have been put out onto this whiteboard here. And the laws should be used precisely as they are stated, so don't be tempted to make up variations of your own. And these are probably the 4 most important laws that you should be using. Okay, so our first law is a to the power of m times a to the power of n. When you have two powers that are multiplied together, then you just add up their powers. So it'd be a to the power of m plus n. If you divide two different numbers that have been powered, that are to a different power, so a to the power of m divided a to the power of n, then you just do the opposite. You are minusing them, so you're taking away, you're subtracting. So it'd be a to the power of m minus n. If you have a power which is to the power of another power, so a to the power of m to the power of n, then you just want to be multiplying those two powers, so that'll be a to the power of m times n. And finally, if you have, let's say, two numbers or two distinct things within brackets, and that is powered, then you want to power everything within inside it. So it'll be a to the power of n to the times b to the power of n, for example here. So let's look at some specific examples of this, so that you can help you really understand and apply these laws of indices. So let's start off with what should be a pretty easy one. So let's say we've got x squared times x to the power of 5. What do you think that would be? Now, if you want to pause the video after I've written down the sums, feel free just to stop the video so that you can have a little think for yourself. So for this one, the right law we would want to look at would be this one here, the first one. So it's multiplied, and therefore we know that we're going to have to add up these two powers together. So we take our x, and then it's just m plus n, which is 2 plus 5, and therefore that equals x to the power of 7. Okay, let's try another one. I'm going to try and make them get increasingly more complex so that you can really understand and appreciate how this works. So let's say we've got 2r to the power of 2 times, let's say, 3r cubed. Okay, how do you think this one would be done? Okay, so we want to rewrite the expression with the numbers together and the r terms together. So we got here a 2 and a 3. So we know that this is going to be 2 times 3. And we also want to put the r terms together. So we've got times r squared times r cubed. Okay. And then it's simply a matter of doing some simple multiplication and then using, again, the first law up the top here. So we've got, this would equal 6 times r to the power of 2 plus 3 equals 5, and then therefore that must equal 6r to the power of 5. Okay, let's try another one. How about b over to the power of 7 divided by b to the power of 4? So the appropriate rule in this scenario would be the second rule here, the second indice rule. And the reason is, obviously, this is essentially a division. So this is saying b to the power of 7 divided by b to the power of 4. And so all we're doing there is taking away m minus n. And that will give us our answer of 7 minus 4, which is b cubed. Okay. Awesome. And let's try another one now. So what about 6x to the power of 5 divided by 3x to the power of 3? So just like we did before, we want to split up the numbers from the powered section. So we want to take it, essentially we want to divide 6 divided by 3 as our first part. Then we want to divide by x5 from x to the power of 3. So times x to the power of 5 divided by x to the power of 3. Okay, and that again leads us into two simple things. So we've got one simple sum here. So we know that 6 divided by 3 equals 2. And then x5 divided by x to the power of 5 divided by x to the power of 3 is x to the power of 5 minus 3. So that equals 2x to the power of 2, 2x squared. So we're just working through these different laws just so that you really get a good understanding of each of them. Because, you know, at the end of the day, these fundamental laws will be applied throughout any maths you do, and the more you can sort of get to grips with them at this early stage, the easier your life will be at a later date when you come across them in your various different equations. So let's try this one now. So we've got a cubed to the power of 2 times 2a squared. How do you think this one would be done? Now, if you get something like this, you should be able to sort of see that there are maybe different rules that are in play, and sometimes you do have to deal with two separate indice rules. And here, specifically, we know that we've got this rule here, and we know we've got this rule up here potentially to play with. So do it by step. So first of all, let's deal with the first section, and we know that this here, a to the power of n to the power of n, would be multiplying them together. So that would give us a to the power of 6, okay, and then that would be times 2a squared, okay. But we know there's still a further inquiry that we have to do. Now, if we split up the terms, we know that will give us 2 as our separate term, and then we've got the a's that need to be put together as well. So we've got a times a to the power of 6 times a squared, and now we've got this first rule at the top here that we now need to apply. So a to the power of 6 times a to the power of 2 must be 6 plus 2 must be 8, so that will give us 2a to the power of 8, and that gives us that one. Let's try something slightly more difficult, actually. I'm sure you're getting the hang of that one now, so let's try something which should test you a little bit more than that. So obviously this is just showing the examples in isolation, but you may get something which is slightly more tricky. How about something, for those that are paying attention, something like this. We've got y squared, and then something like 3 minus 2y cubed. So we've got brackets coming into play here now. Now, again, this is sort of mathematics that you should have already learned by the time you see this video, in terms of how to expand a bracket. But if not, don't worry, we'll explain it now very quickly too, and we'll show how these rules are necessary to simplify this equation here. So Let's expand the brackets first. And to expand the brackets, we want to multiply this together and this together, the inside and the outside here. So that will give us 3y squared minus 2y. Well, what is, obviously that gives us 3y squared because 3 times y squared is 3y squared. But here we've got y squared times minus 2y cubed, okay? And we're going to apply the first rule at the top here, which is the multiplication rule. So we want to separate the terms. We've got minus 2 times y squared times y cubed. Y squared times y cubed. You need to add together the indices, which is y 2 plus 3, which is 5. So you're going to get minus 2y to the power of 5. And so here it's 3y squared minus 2y to the power of 5. And let's try one final equation just to wrap this up a little bit. And I really would recommend you try and do this one yourself if you haven't been doing so already, just to make sure you have followed this through. So write out this equation and have a go at this. So we've got 2x brackets 5x plus 3 minus 5 brackets 2x plus 3. Okay, how about this one? So remember, our first inquiry is to try and expand the brackets. So 5x times 2x is essentially the same as saying 5x to the power of 1 times 2x to the power of 1. And 1 plus 1 is 2, so that would give us 10. Obviously, we're multiplying the 5 and the 2, multiply those two, and then add those two, x squared, so 1 plus 1 is 2. And then here, 3 times 2x, well, we want to separate the terms, so 3 times 2 is 6, times the x, that will give us 6x. And now we've got our separate sort of brackets over here, and you've got to remember that a minus sign outside the brackets changes the sign inside the brackets. So minus 5 times 2x would be minus 5 times 2, which is minus 10, multiplied by the x, which gives us minus 10x, and then minus 5 times 3 will make this into a negative number 2, and that gives us negative 15. Now we haven't quite finished yet, because as you realise here, we have got some terms that can be simplified further because they are the same. So we can simplify 6x minus 2x to give us negative 4x. So that would give us 10x squared minus 4x minus 15. And then that would be the correct answer. So I hope this video helped you out, and that should explain the very basics of the laws of indices. In the next videos, we'll be looking a little bit further into expanding brackets and factorization, but this should give you a quick and easy and simple sort of overview of the laws of indices. If you have any questions at all, just leave a comment below and I'll get straight back to you. Thank you very much.